So, which motor topology should we choose? We're going to look at the induction machine, a permanent magnet machine, and also a switched reluctance machine. Because we know we are focused on energy efficiency. So taking the three different topologies that you see in front of you right now, and we'll look at some of the advantages and disadvantages of these three systems, of these three topologies. The induction machine, it's been around for a long time. We're familiar with that piece of machine, that design, that topology. It's got great for high speeds. It's a simple construction, nice high torque to inertia ratio, high torque density. They are very cost-effective solutions. They don't have permanent magnets, and they have a common drive topology. But some of the disadvantages are going to be rotor losses, less constant power speed range, lower power density, and lastly, lower energy efficiency over the operating range. Now I'm going to pop over to the complete other side of the switch reluctance machine. We see the advantages of this: high speed. Of course, those machines can be very high speed. We see very small ones operating at north of 100,000 RPM. Simple rotor construction. The rotor construction is just a laminated stack, placed onto a rotor. Low rotor losses at low speeds. It's low cost, right? No magnets, and there's nothing wound on the rotor itself. Again, the rotor is just a laminated stack. And no permanent excitation from those permanent magnets. Disadvantages, though, they can get pretty loud, so acoustic noise is something we're going to take a look at. They have complex control systems. The rotor position sensor is required. Smaller air gaps, so the air gaps have to be very small on a switch reluctance machine. Special drive topology, and they have a lot of windage losses. So now focusing on the center topology, the surface mount permanent magnet motor generator. So highlighted right there in the middle, advantage, energy efficiency. So we're looking to get the most energy efficiency, surface mount permanent magnet machine, great machine for energy efficiency. Has the highest torque inertia ratio, highest torque density, good torque control, very low rotor losses, a common topology, and simple construction. Again, we've been producing these for a very long time, so we've got the construction down to the T. Disadvantages are going to be the permanent magnet temperature effects, magnet retention, iron losses, magnet costs. Obviously, magnets do have a cost to them, and excitation during a winding fault. But what we're going to hit now in the following slides is going to be addressing some of those disadvantages of the permanent magnet machine in informing you of what options are out there to address those disadvantages and reduce those disadvantages as much as possible, such as permanent magnet temperature effects. What can we do about that? Magnet retention. There's some new topologies out there with carbon fiber winding, for example. Iron losses. I can use thinner laminations to reduce those iron losses. And magnet cost. We're going to go through a topology which will address how to change the magnet manufacturing method to make them more cost effective.